MCQ with one or more than one correct answer. Question. Two shells are fired from a cannon with a speed u each at an angles of alpha and beta respectively to the horizontal. The time interval between the shots is capital T. They collide in mid-air after time t seconds from the first shot. Which of the following condition must be satisfied? Alpha greater than b, or t cos alpha is equal to small t minus capital T cos beta. Small t minus capital T cos alpha is equal to t cos beta. U sin alpha t minus half gt square is equal to u sin beta t minus capital T minus half of g t minus capital T whole square. Now, when you read the question, what you get it from the question, let us look into. Two shells are fired with speed u, but not simultaneously after an interval of capital T at an angle of alpha and beta respectively to the horizontal. What is the condition that they collide in mid-air? The condition for collision of mid-air will be if a particle starts from here and is projected like this, it goes this way. Another particle is projected with a different angle, maybe like this, and it goes like this. They will collide in the mid-air means if the time taken by this is t, this time taken will be t minus capital T, because the second body is thrown after capital T seconds. So the horizontal distance covered by both the bodies and the vertical distance covered by both the bodies must be same. So the first body should be actually projected at a greater angle than the second body. That means by the understanding itself, here alpha is this angle and beta is this angle. Definitely we are getting alpha is greater than beta. Okay. So let us look into what are the things given to you. For two shells to collide in mid-air, they must reach the same point at the same time. Hence, here the first shell is fired at an angle alpha and has a longer time of flight t. The second shell is fired at an angle beta and has a shorter time of flight. Am I right? Time of flight t minus capital T. So what we conclude? The body which has longer time of flight should have greater angle of projection. So alpha must be greater than beta. This is the first conclusion we are getting. So first option, alpha greater than beta, is the correct option. Let us now look into what are the other conditions. Other condition is the range must be same and also vertical distance. So this y. What I'll do? I'll take the equation of x and y. Range is same. So x for the first body, let us take it. It is the horizontal component of velocity along x-axis u cos alpha into the time taken. This is x1. Similarly, what is x2? Range for the second body, u cos beta into the time taken to strike when they collide in midair, t minus capital T. Now, since range is same, x1 should be equal to x2. x1 is equal to x2 means u cos alpha into small t must be equal to u cos beta into t minus capital T. So, if you look into the option B and C, t cos alpha, small t minus capital T cos beta, this option is also the right option. T minus capital T cos alpha, t cos beta will be the wrong option out of these two things. Also, let us take it for, since range is same, even vertical height will be same. So, vertical displacement. Vertical displacement is same. So, what is the vertical displacement of the first body? y1. y1 is equal to vertical component of velocity u sin alpha into t minus half of gt square. What is the vertical displacement of second body? It is u sin beta into the time it takes t minus capital T minus half of g into t minus capital T whole square. Now given to us, y1 also should be equal to y2. So let us equate these two things. U sin alpha into t minus half gt square should be equal to u sin beta into t minus capital T minus half of g into t minus capital T whole square. So even option D is the correct option. U sin alpha t minus half gt square equal to u sin beta t minus capital T minus half of g into t minus capital T whole square. Option D is also correct. So out of the four, A, B and D are the correct option. So the solution for this particular problem will be A, B and D. This is the solution for this particular question.